In this video, we're going to be multiplying polynomials. So there are actually two types of multiplication that involve polynomials. The first typically involves a monomial times any size of polynomial. And these ones that involve a monomial are actually pretty simple, and most students have really good gut instincts about what they're supposed to do. Because most students have seen something like this before, and they immediately think, let's distribute out that term. And that's exactly what we do here, is if we have a monomial out in front, we distribute it out to each term inside of that parenthesis. Now from here I'm going to utilize keep, change, change to ensure I don't make an error, but this is really all this is. We just have to slow down and think about it a little bit. So this first distribution here is 2x cubed times x cubed. Then we have 2x cubed times 3x squared. And then we have 2x cubed times a negative 2x. And then we add that together with 2x cubed times 5. So here we've written out each little component, and all we're going to do is we're going to take each term and we're going to multiply it out using what we know about multiplying terms that contain variables with exponents. We talked about these when we talked about exponent properties, so we're going to apply our knowledge here. Now in this first term, I notice that 2 is my only number, and then I notice that I have x to the third times x to the third. Now if I go back to thinking about exponent properties, I know this is really x times x times x times x times x times x. So here I have 6 x's being multiplied together to give me x to the 6th. And then I notice here that I remember, hey, if I have two numbers with the same base being multiplied together, all I need to do is add their exponents together. So as a result, here I have 2 times x to the power of 6. Now from here, if I look at the next term, I notice I have 2 times 3, which gives me 6. And then I have x to the third times x squared, and if I use the same pattern that I found over here, then I can simply add those exponents together to give me x to the 5th. This next one here, I have 2 times a negative 2, which is negative 4, and then I have x to the third times x to the first, so again I use the add the exponents trick to get x to the 4th. And then finally, 2 times 5 is 10, and then I have x to the third left over. So here I have 4 terms, and I know that there's an addition sign between each of them. And then if I look at them a little more closely, what I notice right off the bat is they're already in descending order with exponents of 6, 5, 4, and 3, and none of them are alike terms. So my final answer here is just 2x to the 6th plus 6x to the 5th, plus negative 4x to the 4th, plus 10x to the 3rd. Now where multiplying polynomials starts to get a little bit tricky is when we have something like we see on the screen here. So here we have a trinomial times a binomial. So this isn't as easy as the monomial one was. It's a little bit more difficult, but what we're going to use is we're going to use that same concept of distribution. We're just going to use it on a slightly larger scale. So what's going to happen here is every single item inside of this first polynomial is going to be multiplied by every single item inside of the second polynomial. Essentially, it's distribution on a really big scale. So what we're going to do first is we're going to take this first number of 2x squared and we're going to multiply it by both items inside of this first set of parentheses. So I'm going to write that down here. I'm going to say 2x squared, that's my first term in the first set of parentheses. And I'm going to multiply that by 4x plus a negative 3. I'm going to multiply it by both terms. So then I can do that. I can write, okay, I have 2 times 4, which is 8. X squared times x, which is x to the third. And then I have 2x squared times negative 3, so that gives me plus 2 times negative 3 is negative 6, x squared. So I take the first term and I multiply it by both terms in that second set of parentheses. And then I move on. And I say, okay, I'm going to now take this second term and I'm going to multiply it by this second set of parentheses. So here I'm going to write plus 5x times, here I have 4x plus a negative 3. And then I'm going to distribute. So I bring my plus sign down, and here I have 5x times 4x, so that's 5 times 4 is 20. X to the first times x to the first is x squared. And then I have 5 times negative 3, which is a negative 15, and then I have the x. And then finally, this last chunk here, I'm going to utilize keep change here to make sure I don't miss that negative 1. And I'm going to take this negative 1 and I'm going to multiply it by everything in this second set of parentheses. So I have plus negative 1 times 4x plus negative 3. And then I distribute my negative 1, so I get plus negative 4x plus negative 1 times negative 3 is 3. So what I've done here is I've performed the distributive property on a pretty large scale. I took everything in this first polynomial and multiplied it by every term in the second polynomial, essentially distribution on a very big scale. So now that I've done all of my distribution, I want to simplify this statement that I see right here by looking for any like terms. So I start with my highest degree of x to the third, and I notice that there aren't any more x to the thirds, so I'm just going to write it as 8x to the third. And then from here I look for any more x squareds. Well, I notice I have two terms with an x squared, and negative 6 plus 20 leaves me with plus 14 x squareds. And then I look for terms that contain an x, and I see that here with negative 15x and negative 4x, and those combine together to be a negative 19x. And then here at the end I'm left with my constant of plus 3.